This is Algebra 2. This is going to be test number 7, actually. Just week 7, but we're going from 1-1 through sections 5-4. The first problem says, number 1, factor the expression negative 9x squared minus 6x. Take out whatever you can. The things that they have in common. We know that 3 goes into negative 9, or more specifically, we can say negative 3 goes into it. And it also goes into negative 6. So pull negative 3 out. The other thing they have in common is an x. So pull negative 3 and pull x out, and then make yourself a set of parentheses. Then you ask yourself, what do I need to multiply negative 3 by to get 9, or to get negative 9? The answer is 3. And what do I have to multiply x by to get x squared? X to the first power. Because when you multiply x times x, you add x times x. You add the first power plus 1. This becomes x to the 1 plus 1. You add the exponents. So in order to get negative 9x squared, you multiply it by 3x. The other question is, what do you have to multiply negative 3x by to get negative 6x? You multiply it by positive 2. So when this is factored out, if you look at it, you can check it. If you distribute it back, negative 3x times 3x is negative 9x, and negative 3x times 2 is negative 6x. So this is the factored version of that problem. Number 2, it says x squared plus 12x plus 27. Now, this one is not as simple as the last one. What you do is you set up 2 sets of parentheses underneath it. And then you have to work FOIL backwards. So in order to work FOIL backwards, the F stands for first. So what 2 first numbers do you multiply by to get x squared? The only 2 that work are x times x. When you FOIL that, well, when you do the f times f, or the first times the first, that gives you x squared. The second part is you have to look at the last number. This last number, 27. It's positive. Since it's positive, both, in fact, let's not even look at negatives and positives yet. Let's just look at the numbers 27 and 12. Your factors of 27 are 1 times 27 and 3 times 9. That's the only factors they have. So you have to ask yourself, out of those pairs of numbers, which ones can I add together or subtract and get the number 12? Don't even think of negatives and positives right now. Which ones can I either add or subtract and get the number 12? You know that if you put 1 and 27 together, you're either going to get 28 or you're going to get 26. Either positive or negative. Those are the only 2 possible numbers you can get when you combine those, 28 and 26. So those are not the numbers you use. The other ones, when you put 3 and 9 together, you're either going to get 12 or 6. Again, don't even think of positives and negatives right now. Either 12 or 6. So we need the number 12. So those are the 2 correct numbers. So you put in 3 and 9. It doesn't matter which one you put first, which one you put second right now. Then once you have x times x and you have 3 times 9 like that, now you look at the second sign, this one right here, this positive. All that tells you, are they the same or opposite? That's all that one tells you. If it's positive, then they're the same. So that means both of the numbers are either going to be negative, it's going to be negative 3, negative 9, or positive, positive 3, positive 9. And once you know that they're both the same, you look to the other sign, positive. Since they're both the same, that tells you that they're both positive. So we have x plus 3, x plus 9. That is your factored version of x squared plus 12x plus 27. And the reason we have x plus 3 times x plus 9, again, if you FOIL these numbers back, it'll get you back to x squared plus 12x plus 27. Let's see if that's the case. The first 2 numbers, f stands for first. X times x is x squared. Then the O stands for the outer 2 numbers. X times 9 is positive 9x. Then the I we know stands for the inner 2 numbers. So 3 times x is positive 3x. And then the L in FOIL stands for the last two numbers. 3 times 9 is positive 27. So now we have x squared plus 9x plus 3x plus 27. And we have to combine 9x and 3x. And that's why right here in this spot, you have to add them because you got to add 9 and 3x to get 12x. Then when you look at it again, it goes back to the original problem, x squared plus 12x plus 27. But this is your factored version. Okay, number 3 says x squared minus 14x plus 45. We got a couple of more factors of this one. But you open up 2 sets of parentheses again. In order to get x squared, you have to multiply x times x. So we start there. Then you list the factors of 45 because that's the constant term in your trinomial. 1 and 45 multiplied by each other get 45. 2 doesn't because 2 times nothing gives you 45 because it's an odd number. 3 goes into 4 one time and there's 1 left over. So 3 can multiply by 15. 4 doesn't multiply by anything. 5 multiplies by 9. 6, 7, and 8 do not multiply by anything. So notice as you're going down this number, you're going up this one. And when you get closer, the closer the numbers get together, you finish with the factors. So now you look at those pairs of numbers. Out of 145, 315, and 59, which one of those, when you put them together, again, don't think of positives and negatives right now, just think of combining them, will give you the number 14. When you put 1 and 45 together, you're either going to get 44 or you're going to get 46. So we don't want those numbers. We want the number 14. When you put 3 and 5 together, you're either going to get 12 or you're going to get 18. That's not 14. When you put 5 and 9 together, you're either going to get 4 or you're going to get 14. So those are the numbers we want because we want 14. So you take 5 and 9 and you plug them in right here, 5 and 9. Again, the order doesn't matter because we haven't put in a plus or a minus yet. After you have your x's and you have your factors in there, look to this sign here. It's positive. Remember, that all that one asks you or tells you, are the numbers the same or are they opposite? If it's positive, then they're the same. So that means both of them are either going to be negative or both of them are going to be positive. So you look to the last sign that's negative. They're both the same. That one tells you they're both negative. So x minus 5 times x minus 9. Again, if you FOIL, so that's the correct answer for factoring it out. If you FOIL that back, you do x times x for f, you get x squared. You do x times negative 9 for outer, you get negative 9x. You do negative 5 times x for inner, you get negative 5x. And you do negative 5 times negative 5 for last, and you get positive 45. And when you combine negative 9x and negative 5x, you get negative 14x. Put the rest of it down. And you go right back to what was original. We have x squared plus 3x minus 18. Again, factor it out. Open 2 sets of parentheses. X times x gives you x squared. You have to factor out 18. Again, don't look at positives and negatives yet. Let's just factor out the number 18. 1 times 18, 2 times 9, 3 times 6. Those are the only factors of 18. So which pair of those numbers gives you the number 3? Again, don't think of positives and negatives yet. Which one gives you 3? 1 and 18 are either going to give you 19 or 17. 2 and 9 are either going to give you 7 or they're going to give you 11, not 3. And 3 and 6 is either going to give you 3 or 9. So that's the pair you want. So in place here, put in 3 and 6. So again, we don't have pluses or minuses yet. You look to the second sign. This one tells you it's negative. Remember, that asks you, are they the same or are they opposite? If it's negative, then they're opposite signs. That means one of them has to be plus and one of them has to be minus. You look to the first sign, plus. That one tells you since they're opposite, the larger number is going to be plus. So the larger number out of 6 and 3 is 6. So that one's plus. The other one is minus since they were opposite. X minus 3 times x plus 6. Again, if you FOIL it back out, x times x is x squared, x times 6 is plus 6x, negative 3 times x is minus 3x, and negative 3 times 6 is minus 18. When you combine your like terms, 6x and negative 3x, it leaves you with 3x in the middle, and you go back to the original trinomial from the beginning. Number 5 says 9x squared plus 30x plus 25. Now, for this one, there's a coefficient in front of x squared. So it's not as easy as the other one. However, this is two perfect squares. You can look at the first number in the trinomial, 9x squared. We know 3 times 3 gives us 9. So 3x and we know the last number in the trinomial, 5 times 5 gives us 25. So that's 5. So 3x, because 3 times 3 is 9, and x times x is x squared, and 5 times 5 is 25. Notice we didn't put anything between 3x and 5 yet. You look to the last part of it, you look to this plus right here. That tells you that it's going to be 3x plus 5, and the entire thing is squared. Again, this is just a special circumstance. However, you can FOIL this back out to see if it gives you the original trinomial. This is the answer, but if we FOIL it back out, 3x plus 5, when you multiply that by 3x plus 5, because that's just squaring it out, FOIL it, 3x times 3x is 9x squared. The outer terms, 3x times 5 is plus 15x. The inner terms, 5 times 3x is plus 15x. And 5 times 5 is plus 25. When you combine 15x and 15x, 30x. Notice it goes back to the original trinomial, 9x squared plus 30x plus 25. Number 6 says 36x squared minus 25. This one might make why we squared the last one make a little bit more sense to people. When you're talking about the difference of perfect squares, again, we got a perfect square, 36. We can multiply 6 times itself to get that. And we got a perfect square, 25. We can multiply 5 times itself. It's the difference because they're subtracting. So the difference of perfect squares is 6x plus 5 times 6x minus 5. 6x plus 5 times 6x minus 5. Anytime you see something, again, this is another special circumstance. Anytime you see the difference of perfect squares, x 6x plus 5 times 6x minus 5. This one says 2x squared. Now notice the difference between 1 through 6 and this one. There's an equal sign for this one. 2x squared equals 10. Do the inverse of everything. We know PEMDAS gets us to our order of operations, but when you undoing it, you work backwards. So any addition and subtraction, no, there's none. So we're done with that part. Any multiplication and division, yeah, you can see 2 times x. So divide by 2 to cancel out 2 times something. If you divide the left, divide the right. These will cancel and leave you with x squared on the left, and 10 divided by 2 is the number 5. Then we know to undo or to cancel out, we're done with multiplication. In order to cancel out squaring something, this is this part, take the square root of it. That'll cancel it out, but you have to do the same to the right. X is equal to the square root of 5. Remember, that's a positive square root of 5 or a negative. So x equals plus or minus the square root of 5. Number 8 says the square root of 147. Remember, you want to take a perfect square out of it. 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. The square root of 49 multiplies by the square root of 3. And the square root of 49 is 7 times the square root of 3. Square root of 450 over the square root of 10. The first thing you do is separate the square root of 450 and the square root of 10. Then break down the square root of 450. If we do it out here to the side, we'll see it a little bit easier. We know that 9 goes into 45, so we'll start there. The square root of 9, it goes into 45 5 times, so 9 times the square root of 50. When you break the square root of 9 down, you get 3 times the square root of 50, which we know we can break up into the square root of 25. That's another perfect square times the square root of 2. So you have 3. The square root of 25 is 5. So 3 times 5 times the square root of 2, or 15 at the top of it times the square root of 2 over the square root of 10. Then we have to get rid of the square root of 10. We have to rationalize that by rationalizing the denominator. Whatever the bottom is, it says the square root of 10. You multiply it by that over itself. So when you multiply straight across, you get 15 times the square root of 20 over the square root of 10 times the square root of 10, which is the square root of 100, which simplifies right back to 10. From there, we can break down the square root of 20 again. We know the square root of 20 breaks down into perfect square 4 times 5. So you have 15 times the square root of 4 times the square root of 5 over 10, or 15 times 2 times the square root of 5 over 10. 15 times 2 is 30 times the square root of 5 over 10, and 30 divided by 10 is 3 times the square root of 5.